The next presentation, fourth presentation, is the title is a walk path planning for automatic operation concerning the motion performance of a Paddy field weeding robot. So the presenter is Mr. Uchida. It's okay. Please prepare.
Okay, can you hear me? Can you
Yes,
hear me?
and please share of your. Okay.
Okay. Can you see?
Yes, I can see. Yeah, and we can see.
Okay.
Okay, please start.
Okay. Okay, thank you for the introduction. Today, I'd like to talk about development of automatic operation system considering scaling performance for a Paddy field weeding robot. This is the content of presentation. My talk is divided into 7 parts. First, I'll start with talking about background. In agriculture, weeding methods that do not use herbicide are attracting attention. Such as previous research, there was a method of operating a weeding robot with a controller to weed. As a result of previous research, it has success in reducing the weed growth by weeding from 5 days to 1 month after rice planting. We assumed weeding environment. The velocity of weeding robot is based on the request from the farmer, 0.5 to 1.0 meter per second. Next, in recent years, it has been paying attention for automatic driving system for agricultural vehicles, for example, tractor and combine. Those can accurately follow a made target path. As main advantage of introducing an automatic driving system is the following 2 things. First, improvement of work efficiency and production. Second, reduction of workload. Next, talk about using weeding robot. As the driving unit divided into 2 parts. First, propulsive part. Second, steering part. However, the steering motor is configured so that the turning force differs between the right turn and the left turn. It is necessary to design the work route according to the performance of the machine. Therefore, I would like to talk about the following 4 purposes. First, development of automatic operating system. Second, clarify the turning performance of the steering motor. Third, the work path design based on the turning performance is described. Fourth, we conduct automatic driving control experiment on a work path that takes into consideration turning performance. Next, about the overview of the weeding robot. Please show this table. This table is specification of weeding robot is like this. Weight is 8 kilograms. And at the rear, 12 chains are attached, and the length is about 700 millimeter, and then the length of the bar is 900 millimeter, and a metal hook is attached to the chain as a weight to prevent it from flowing on water. Next, the driving unit is divided into 2. Steering motor is moving clockwise and counterclockwise. A promotion motor is only moving counterclockwise. Next, about the mechanism of the weeding work. First, tracking the chain with the weeding machine. Second, chain star Paddy field. Therefore, weed seed surface on the water because it will take root about 5 days after rice planting. Rice plant will not come off. Third, preventing weed growth. Next, about Autorun control system. A Raspberry Pi is used as a main computer, and then based on the data from the GNSS sensor, using Arduino to drive motor. Next, about overview of automatic driving system. The automatic driving control system used to process the difference between the latitude and longitude of the current position obtained from the GNSS sensor and the latitude and longitude of the target point. A GNSS sensor used RTK positioning. Next, about overview of the output judgment in the steering control parts. This used angle error. If it is within the reference value of the angle error, output value is 0. If it exceeds the reference value of the positive or negative angle error, output value is instruction the right turn or left turn. Next, about the output mode of the motor. Output motor is the pulse value of the radio controller. It is set in the program in advance. And then there are two modes of motor output. First, straight ahead mode. In straight ahead mode is previous propulsive motor is large output. Steering motor is small output. And second is turning mode. In turning mode is propulsive motor is small output. Steering motor is large output. And then steering straight ahead mode is the promotion force of the promotion motor is increased. And when turning, the steering force of the steering motor is increased. Next, confirmation of motion performance for the weeding robot and work path planning. Confirmation method, we made a right turn and a left turn for 5 seconds and investigate the turning angle of the weeding robot for evaluate turning performance. As a performance evaluation, I found it better to left turn. It is a work path designed from the experimental result. This time, I designed two work paths for comparison. Number one is rotating both directions. Number two is rotating only left turn. Next, about experiment of Autorun. The automatic driving experiments are conducted at the pool in National Institute of Technology Research College, and then target path data created from Google Map. And then please show this table. This is value of motor. The first mode, straight ahead mode is a red color, and turning mode is blue word. Please show this move. This is experimental of number 2 target path. Okay, next. You can see from the figure that it follows the target path. But in the target path number 1, point A makes a large turn. The performance of turning right is bad. Number 2 also has a slightly deviation from the target path, but you can see that the figure on the target path number 2 is more accurate. Next, since the work speed requested by farmer is 0.5 to 1.0 meter per second, it can be seen that the requirements are met. Next, from the figure, it can be seen that the program outputs the motor accurately. And then it can be seen that the target path number 1 has more switching of the steering motor. Also, if you pay attention to the blue line of number 1, compared to number 2, it can be seen that more turning correction is conducted in straight mode. Therefore, it can be seen that number 2 has less trajectory correction and better accuracy. Finally, the conclusion from this study we got about the following 3 things. First, we constructed an automatic driving system that controls propulsive and steering motor based on GNSS sensor information. Second, the motion performance due to the turning torque was clarified. And the backpass was planning considering the output of the turning torque. Third, the route planning method considering turning performance is effective. In the future, I would like to proceed with my study in this way. In agriculture, field work is Paddy field. The working environment changed, such as wind disturbance and rice plant resistance. In the future, we will build a feedback system based on the mathematical model of the weeding robot and develop an automatic driving system with a control system that is robust against disturbance. Thank you for your kind attention.
Thank you for interesting. Thank you for interesting presentation and introducing the good robot. So, do you have a question or comment from audience? Okay, I have a short question. Does it have? Does the robot have any external sensor such as a camera or GPS and so on?
Okay, thank you for the question. This weeding robot is only GNSS sensor.
GPS, GNS.
Yes, GPS sensor.
GPS. Oh, okay. And so I have one more question. So the robot have chain, the severe chain, which is made by plastic, and so is it enough to reading the mechanism? Or so do you have other better solution or mechanism?
Mechanism. Okay. So this mechanism is
so is it enough to reading using this mechanism?
Yes.
Enough. So do you have other method? Or better method than
better method.
Okay. This method, yeah.
Okay, this method is considered to be less likely to damage the rice because it follows on the water, except for the chain. We believe that this weeding mechanism is a method that can feed without damaging the rice. Yeah, however, if the rice grows, the propeller may hit it. So I would like to take measures such as attaching a cover to prevent the propeller from hitting the rice.
Okay. Hi. So, do you have other question?
I have a question. Obviously what you're trying to do is to stir the weed seeds within 5 days of planting the rice. What happens if the seeds don't come to the surface? Some will do, but others may not, and then the weed begins to grow. What do you do then?
Okay, thank you for your question. Why is a weeding period of after the 5 days to 1 month? After the 1 month, after the 1 month, to grow the weed, cannot move this machine because this price is only 5 days to 5 days from 5 days to 1 month from after the rice planting.
Okay, is it okay? Okay, so
It's okay.
okay. It's time to go. It's time to go.